welcome folks to Defender Fridays. And again, huge thanks to Matt Bromley, my colleague, for stepping in, and he's my co-host anyway, right? So for him helping us and keeping the show going. And as I understand it, our guest today, Michael Smith, was actually on just a couple weeks ago. And it's funny because Michael, I think the intended topic for that session was
DGAs.
DGAs, right? And I think is, as I heard, that we didn't get a chance to cover that. I think the conversation went a different direction, which, hey, that's awesome. I mean, like, let it go where it goes organically. I think that's great.
Yeah.
But you were pretty insistent on talking about this topic, and I'm excited to actually be, on for this topic because it's such a fascinating concept. And I don't know if you and I had this conversation, but I posted something on Twitter a couple weeks back. It was in response to looking at some of the well-known bypasses for a lot of EDR products. It's a really tricky problem to solve. It's the fact that, hey, if we can identify the C2 domains that the EDR relies upon, and I know Jeff knows all about this, if we can interfere with that communication, right, like sinkhole it by modifying the host file or whatever, then we could break an EDR. And the reason that for me got into the idea of DGAs, I'm like, it would almost make sense for EDR to adopt, the DGA concept, because then like it becomes harder to kind of sinkhole it. There's cat and mouse, right? There's an infinite back and forth that could go on there. But anyway, so thanks for coming back on, Michael. Real quick,
Yeah,
just
no
to
problem.
kind of set the stage in case we've got any new faces on here, because we get new registrations every week. So for anybody that's new, welcome to Defender Fridays, folks. So the idea, the meaning behind this webinar is to have a short and sweet informal dialogue with industry experts that are doing cool and interesting things in defensive, offensive, and everything in between in the security space. And it's to really just foster the ability to kind of build community, to share knowledge, to collectively raise the bar in the mission that we all have, which is, defending our enterprise organizations and, imposing cost on threat actors. So, Michael, thank you so much for joining us. For anyone that did not get a chance to catch Michael a couple weeks ago, Michael's the CTO of, I'm drawing a blank,
Vercara, yeah. Software.
And Michael and I actually crossed paths in another InfoSec community. I'm going to give a quick shout out, VetSec, which is a not-for-profit organization for veterans that are either in the cybersecurity career field or trying to get into the cybersecurity career field. So if any of you have a military background and you don't know about VetSec, absolutely worth looking into. Join that community. It's full of amazing people just helping one another, sharing educational information and industry information, and a lot of really cool stuff goes on in there. And that's actually how I discovered Michael. So I had to give a shout out to VetSec for that reason there. But awesome, Michael. Let's hear about DGAs. First of all, what is a DGA?
Yeah, so a DGA, and I'll use the DGA a lot. It is a domain generation algorithm. Okay, and so what you do is you're a fisher. Fishers do it, and you've seen it, right? You've seen like www-irs.go, right? Which is like go. What I don't even know what kind. CCTLD that is. But they will generate domains that are semi-random, right? They're not completely random, but they'll generate them that are semi-random, and then either they'll use them in phishing, which is one problem set, or they'll code that algorithm inside of malware, and then they'll run it outside of the malware, and then they'll go register some of those domains and point those at their command and control. So the whole idea is, as we got better at defenders as blue teams, you go and you say, oh, Joe got his machine popped. Let's go look at what he's got there. We pull a piece of malware, we stick it in a lab, we blow it up, and we say, wow, it made DNS queries to this domain. So let's go block it, right? Common sense. Over time, what we did is everybody started sharing their lists of domains. Right. So either you trade it with your friends, like trading Pokemon cards, or you traded it through an ISAC or, Mist, some kind of threat intelligence platform where you'd share them up programmatically or through some kind of application, and then everybody else would pull those down and they would look at them, right? Even at some point, if you've ever used Pi-hole, Pi-hole is it's a Raspberry Pi piece of software you put on Raspberry Pi. It's a DNS server for your home. And there were a bunch of lists. Firebug is probably the most famous, where you could go download lists where people had contributed these are bad domains. Okay. And so we got pretty good at doing that. And I think most modern folks, right, or most modern folks, that's all of us. Most folks at least got used to the idea of here's a list of bad domains, let's block it at our resolvers. Okay. In order to compensate for that, because it is an arms race, do you have ad lists? It might be under like ad lists. They have, so you can go grab these different lists and Pi-hole will suck it up and start blocking those. Okay. And there's a more advanced version of that that's called a protective DNS. And a protective DNS is a service. My company has one, but you point your resolvers and say, okay, my on-networker resolvers are now forwarders, and the protective DNS does all the blocking. It's just a resolver that does filter, right? And so going back to where I was at, the attackers started using these random generators pseudo-random generators in order to create domains so that they could code that in their malware. So if you block the main command and control, they would beacon periodically to these other domains to say, oh, okay, now I need to, it's just like a way to avoid that DNS filtering, right? And a lot of malware uses the DGAs not as their primary command and control, but as a beacon or a keep alive or hey, I need to get my updates because I see that my main C2 is being blocked. So that's the fallback C2. Okay. And so that's what DGAs are. There are tons of them that are out there. One of the phenomenal resources that I found, and I did a lot of research last year and the beginning of this year, simply because we operate a recursive DNS, like an open public recursive DNS, right? And we go through that and we look for things like DGAs. And we had a feed from a provider, and they basically say, here's a bunch of domains that look like DGAs. And we would go through our logs and say, oh yeah, which ones are active, right? Which ones are being used currently? And we would use that as seed data. So you say, here's a domain. We know that it's malicious. What IP address does it resolve to? What other domains resolve to that IP address? What other domains are registered with the same like domain owner, the same registrant details? What name servers do they use? Authoritative name servers. What other domains use those name servers? And you can start to score and do all the big data stuff that makes that protective DNS like service work. Way overkill for your average person, simply because you need a handful of people that have a background in data science and infrastructure management. So our provider that we got the list of domains from, and they just, they reverse engineer the algorithm, and then they run it and they say, these are candidate domains. The service provider said, nope, we're not going to provide this anymore, right? We don't want to be in that business. And we kind of went, okay, who else is offering this? So I did a lot of market research. Who has feeds like this? There's really only a couple people that offer feeds that have DGA candidates. One of those is John Bambenek. So Bambenek Labs. He's got a list of them. And I'll drop that into chat. Oh, this goes to everybody. Okay. I think I put my company name into chat, but I think I sent it to everybody. Yeah. Okay. That went to everybody. Okay. So you can go get a list from John Bebenick, and he's really good at that. But I started looking around for alternatives and just researching what are these things? What do they look like? I found a fantastic resource that is Johannes Bader. And Johannes Bader is a malware reverse engineer. Okay. And he goes through and like his fun and his job is to go take malware, rip it apart, reverse engineer the algorithm, right? How does it determine its domains? And then he did the most awesomest thing for the planet, which was to create or basically re-implement the DGAs in Python and make it available on GitHub. Okay, so I will put his GitHub repo into chat. Okay, so as I'm researching this thing, I'm like, wow, this is a fantastically good resource. It really helps to understand because for each DGA that he's reverse engineered, he has here's the DGA. It's implemented in in a really simple language. So, and it's open source. You can go mess with it. You can go poke around it, see how it works. And he has a list of these are the types of domains that it generates. Okay. And so I started looking at that and I said, hey, wait a minute, we could generate our own feeds. I took this implementation and several other implementations of algorithms. We put those into a wrapper that basically said, take all the permutations for this algorithm and generate a list of domains. And then we go back and look through our logs and say, have we seen that traffic? Okay. Now, the DGAs themselves, you can dig into all of it. Some of them, like the early ones, the first ones, didn't, they just ran and made domains. Okay. Well, those were easy. You just reverse engineer it, you run it, and hey, you get a bunch of domains and you go block them, right? That was too easy to defeat for blue teams. So they started adding in values. So they'll add in a value like the current date, right? That could be a seed value. They could have magic value. Yeah, magic value is like a salt, or what I think of as the subscriber ID, right? So somebody makes malware, they just leave a little placeholder in the config, and then when you go deploy your C2 and everything, you just put in the right seed value, and it's like the affiliate ID, right?
Wow.
So that your malware only goes to your C2. So there's a magic value or a seed value that's in there. Some of them, and Gozi is one of the fun ones to look at if you have time to look at it. It uses a dictionary file, right? And it uses the ones that I've seen are the GNU public license, so GPL, version 2, in case anybody wants to really get that nerdy. The Declaration of Independence, the U.S. Constitution, Martin Luther's 95 Theses. And basically these are HTML documents that are out there on the web. They hand code the URL or hard code the URL into the algorithm, and the malware or the algorithm reaches out, grabs that file, does a HTML to text. It basically generates what big data guys call a bag of words. Right? Simple concept. It's basically every word that's in the document gets put into the bag. And then what they do is they say, I want a domain that is a certain length, right? I want it to be 28 characters, 24 characters. I grab a word. Is it less than 24 characters? If it is not, or if it's still less than 24 characters, I grab another word and I just stuff them together until I get a domain that's long enough. And then they have a list of top level domains that they register that domain on. So the whole idea there is that you get domains that look kind of human readable, right? But some of them are just complete trash. It's just like random stuff. CACBot is fun. It has a lot of Q's and Z's and X's. So you just look at it and you're like, oh yeah, that looks like CACBot. Interesting stuff, right? So the question is, how do we find it, right? And how do we deal with it? What we do in my company is we run the algorithm with all the permutations. So I say minus 10 days, plus 10 days if it has time. If it has seed values, we use all the known seed values for that algorithm. If it needs a dictionary file, we provide the right dictionary file. But we create, here is a huge list of domains, and then we go check through our logs to see where we found those. Okay. But we've got millions of users hitting a recursive, so that's easy to do. For the average person that's out there, some of these you can run your own and just implement them as a block list, right? And just say, okay, cool, I'm worried about this one. Here's the list of domains, drop it in as a block list. But because of the size of all the available domains, it makes it really, really hard to do. Okay. And so let's see. There's a couple things in chat here. It's high entropy, yes. And let me show you a couple of these if I can.
Yeah, yeah.
I am disabled. I can't do it. Okay.
Here, I'm promoting you. You got it.
All right. Ooh, all the power. Okay. So I'll show you some examples of what these things look like, right? And Johannes has these in here. So you want to look at Gozi. Here's Gozi. He has example domains, right? And you can see these, Quad Presidente Max Saget. The reason why is because he's going from Martin Luther's 95 Thesis, which is written in Latin. Okay. And so you can kind of see that. I have a big presentation that's basically threat hunting with recursive DNS. Other examples that are there. So this is Bumblebee. It's like randomstuff.life. There's Gozi, which you saw. I do have a CACBot, looks like this, right? A lot of these, you can just look at them and go, yeah, you know what? That's something suspicious. Now, the trick is, can you identify these programmatically? Yes, right? You could build a regex that says, if the domain has 4 or more Qs, Xs, and Zs, then identify it as CAC, right? You could do that. You could do natural language processing. Yeah, like that's not English. Okay. Or you could do like Gozi. Gozi gets harder when it's in English, but you could say, here's the maximum or minimum length, and then start looking at domains that are bigger than a certain length and that don't have the same kind of entropy as English. A bunch of different things, but really some are a static list of domains, right? Really easy. You run them once, you get a list, block it. Have a nice day. You can build your lists of candidate domains like we do. There's a pattern, and a lot of these you can build a regex for, and you can look specifically for them. They still have to go to some infrastructure. And that's what we do is we say, here's a domain that's a DGA. Let's go find what IP address, what network block does it resolve to, what name servers does it use, like all of this other data that we use to actually detect, yes, that's a malicious domain. And then the usual things, right? So domain age, right? Domain age catches a lot of stuff. So that means that the attackers have to think out in advance, which allows us to build domain reputation before they actually have a chance to use it. Most people will block a domain that's 30 days or younger. In my very paranoid mode, I block 90 days or newer. Some people will do, like when you do reputation scoring, they will score all the way out to 12 months old. Right? And so they'll use that to score their domains. There's no normal traffic. We actually use that in our logs a lot. We look at it's called the long tail in marketing, right? So you take these are the domains that are queried a lot, get rid of the top 90%, right? Because most of your DNS queries are going to be Google, Microsoft, Outlook.com, Apple, stuff like that. So get rid of the top 90% of domains by volume and start looking at what's left, right? And you'll find a lot of Mike's Cat blog, okay. But you'll also find all of your malware there. Usually suspicious domains don't have they don't have like MX records, they don't have like text records for Let's Encrypt. There's a bunch of stuff that you would expect a domain that's lived in to have, and you don't see a lot of that in the DGA domains. Okay.
So Michael, actually, I'm curious. I'd like to get some thoughts from the audience for sure. But I have a quick question for you. So I know that the terms ML and AI have been kind of really driven into the ground by the marketing engines of this industry. However, this feels actually like one of the most prime and easy to reach candidates for machine learning, right? Because so much of the detection of this is that very basic anomaly detection, right? And so have you done any work with ML to try to identify these without the use of patterns and regex?
We haven't I haven't gotten to that point yet. Okay. I do have folks that built the protective DNS part. They go through a lot of that. But I personally haven't done it. Yeah, right. And they do, like I mentioned, they do all of the data mining for the infrastructure, and then they run, AI and AI-ish type things over the top of it. And yeah, that helps them to identify things. So really, there are two ways that you could say, here's a domain that we know is bad. Here's a brand new domain. We've never seen it before. There are two ways to do it. One is a bunch of nested if statements, and the other way is a thinly disguised bunch of if-then statements, right? So you could go in and you could say a scoring, and if you say, okay, if the say the IP address is on a list of known bad IP addresses, then we raise the score by 5 points, right? And so you do it you just keep score and you add points to it. Or you could do like a supervised learning approach to say, these are known bad domains, and here's all the data mining behind them. Now, for this new domain, categorize it, right? And really, almost all security problems, at least blocking and, like protections, it's a categorization problem, right? Hot dog, not hot dog, malware, not malware. And so, yeah, it does lend itself to supervised learning. The hard part, the incredibly hard part, is being able to do that with 10 millisecond latency because it's a recursive DNS server. Okay. And there are a bunch of tricks around it. Like you can put a caching resolver in front of the resolver that does all the AI, ML, high speed stuff, because that caching resolver will actually cache the computed answer, and it serves as offload. Okay.
Michael, do you mind if we drop the screen share just because we're coming up on time, and one of the things that we try to foster here at Defender Fridays is more face to face and bidirectional. So I'd love to hear from anybody here. Has anybody worked with detecting or combating DGAs? I know Ben, I saw your comment in the chat, Ben. Love that. Thinking of ways of just using passive lookup lists, like for instance what we support in Lima Charlie, so that we're not maybe taking as invasive or intrusive sort of actions unless we want to, but leveraging sort of that telemetry. And the other thing, Ben, that I'm still waiting on somebody to come up with this idea is using for instance, in Lima Charlie, we support the outputs, right? So you could take just specific DNS query data and feed that into an ML algorithm and train that thing and look for those anomalies that way. Like, if I had more time, I would totally want to dive into that. Ben, I nominate you. I know you've got the chops.
It's actually not a bad call. That would be a way to kind of just gather all of that data together and have it as just like a constant stream.
Right? Because again, not to get pitchy here, but it is one of the cool things about LC that you can selectively carve off just that one little sliver of telemetry, just DNS query data, and send it anywhere you want, like Google BigQuery or whatever, and that offers some pretty cool opportunities.
I'm going to be the cold water for a moment. When the base rate is so low, like how out of all the DNS domains that you query, how many are going to be considered malicious or DGA, etc. Anytime you have any kind of ML classification, it's really, really hard to get the false positive rate down enough when the base rate is so tiny. It's the TSA problem, right?
Yeah,
You're going to be
and then
optimized for not having false positives, and where the false negatives are going to be significant.
yeah, exactly, and that
my biggest
is
concern.
going to be the problem, and you'll see that a lot with unseen domains, right? Brand new domain, nobody's seen it. God forbid somebody calls it a 0-day domain. Just that's like, I catch people doing it, and I kind of throw up a little bit. But yeah, those are the ones that are going to be the problem side of it. There are things that help, right? One of those is just we subscribe to a lot of other threat intelligence feeds, and then we take those feeds. Yes, you take the feed, you block it, but you also use that as seed data for data collection. So that helps out a lot. And there are a lot of folks, that they run feeds just of domains, and so you can hook up to that pipeline and you grab all of those. So it's really sort of like crowd hosting domains so that you can test them, and it increases the odds that you've already seen that domain before. Okay. So yeah, right. But it is hard because you have to do it in a timely manner. That's the hardest problem. If it's after the fact, I've got logs, let's go dig through the logs. That is relatively easy to do, but doing it live in line, that's the hard part.
That MTDD, right? Or MTTD, trying to cut down that time to detect.
The time to detect. Well, it's not even that. It's DNS. And so if DNS doesn't respond timely, then everything else goes kablooey, right?
Exactly right.
And you run into making a lot of weird engineering decisions, like what happens if we don't get an answer and it's been 100 milliseconds?
Yep.
Right? Do you fail? Do you fail silently? Do you fail with a splash page that says, hey, this is under analysis, give us a minute, we'll get back to you? Or do you allow it, knowing that you haven't seen it, right?
Fascinating stuff, Michael. I love this. This is amazing. And we could probably keep going for another half an hour.
We could probably go for a long time, yeah.
But we are at the top of the hour, folks. So let me go ahead and wrap this thing up. So real quick, couple of housekeeping notes, folks. So hey, next week, next Friday is the 5th of July, which, as you all know, shares a close proximity to the 4th of July. And we expect that most folks are probably going to be out and, on a 4-day weekend. I hope some of you get that ability. So we are actually not going to have an episode next week, but we will be back the following week. One other quick bit of news that I'd like to share, because it's super exciting and I just want to get it out there, is for anybody that's previously familiar with the CTF that Whitney and I and our former team ran, called OpenSock. OpenSock has been deprecated. However, something cool that's coming under the LC team is a new defensive CTF that we are debuting at DEF CON this year. More details to come here very soon. Follow the Lima Charlie socials if you want to be the first to know about it. We are pumped. It's going to be a ton of fun. So more to come. But otherwise, folks, have a fantastic rest of your day, a great weekend. We'll see you in 2 weeks, folks. So take care.